Hi everyone, I'm Manas Abhay from ADYPU University, BTech Section E, ITDS and DCBC. Today I'm going to explain the physical operation of PN junction diode and as well the classification of PN junction diode. First of all, we are going to see a physical operation of PN junction diodes. Now, this particular image shows the case of unbiased diodes as there is no flow of any current and neither there is attachment of any battery. So when p-type semiconductor is biased with n-type semiconductor, there is a formation of a layer which is also called as depletion layer. But why it is called depletion layer? Where p-type semiconductor has a majority charge carrier as holes, which means this p-type semiconductor is tend to be a positive part and n-type semiconductor where the majority charge carriers are electrons, which in case makes this n-type semiconductor a negative part, makes this depletion layer or this layer total neutral, which means there are no any flow of current and there is no any charge carriers in this part. But what is p-type semiconductor and what is n-type semiconductor? So first of all, we are going to see p-type semiconductor. So p-type semiconductors are trivalent semiconductors, which means when trivalent impurity atoms do with semiconductors or other impurities, they tend to have a hole in it, which means they have an absence of electron in it. Whereas when n-type semiconductors are called pentavalent semiconductors, which also means that pentavalent impurity atoms, when doped with other semiconductors or other impurities, they tend to have a free electron in it. But why this p-type semiconductor is called p-type and n-type semiconductors are called n-type? With layman's language, we can say that when there is an absence of electron in it, this whole system or this whole semiconductor assumes to have a positive charge. But when there is an extra electron in any system, this assumed to have a negative charge, which says it an n-type semiconductor. Now we are going to see when unbiased diode come under presence of flow of current. So when unbiased diode is come under the flow of current, there are two possible cases. First is forward bias and second is reverse bias. So what is forward bias? Now, when the external potential is opposite to the internal built potential, which means, in easy words, when positive terminal is attached with the P region and negative terminal is attached with N region, there is a formation of forward bias. As you can see here, the electrons tend to move this way. Also, the electrons in depletion layer moves this way, which automatically reduces the depletion layer. Whereas n-type semiconductors are concerned, the positive terminal is attached at N region and negative terminal is attached at P region, which is exactly the same of internal build potential. That's why there is no flow of current, also negligible flow of current. The flow of current in forward bias is always milliampere, whereas the flow of current in reverse bias is always in a microampere. Now we are going to see the characteristics of PN junction in respect of potential and current. So till now we have saw what is p-type semiconductor, what is n-type semiconductor, what is depletion layer, what is forward bias, and what is reverse bias. Now we are going to see what is the characteristics of PN junction diode. Now, as you can see here, there is a graph. This particular region, consider it for forward bias. and this particular region for reverse bias. Now, as we know in forward bias, the current is always milliampere, and in reverse bias there is always microampere. Now, as we all know in semiconductor there is always a very less flow of current. As well as you can see, when there is increase in voltage, you can see there is a little bit increase of current. But as soon as the forward bias voltage becomes equal to or more than the barrier voltage, which is in depletion layer, there is a sudden increase in current. Now, in reverse bias, as you can see, as we all know, in reverse bias there is no flow of current. There is very negligible flow of current. There is a microampere flow of current. Now, there's only a one flow of current, which is saturation current, which is also known as leakage current. Now, when there is increase in a reverse potential, as we all know why this region is forward region, as the potential here is positive and here is negative, means here is forward potential and here is a negative potential or reverse potential. When the reverse potential reach at breakdown voltage, there is a sudden increase of current. Now, why it is a sudden increase of current? When the potential reach at the breakdown voltage, the electrons tends to have increase in kinetic energy, which means that as there is increase of kinetic energy in electrons, they tend to move freely. And as they move freely, they collide with other electrons, which increase the flow of electrons. That's why when the potential reach at the breakdown voltage, there is a sudden increase of electric current in it. So this is the end of my presentation. I would like to thank Professor Dr. Vivek sir for allowing me to do this project, as well as to all the people who helped me to make this presentation possible. Thank you.